Algebra 2, Set 100, Graphs of Parabolas. Okay, so this lesson is about graphing parabolas, but before we talk about the graphing, let's just talk about quadratic equations really quick. The equations that I have listed above are called conditional equations. You can solve for x a couple of different ways. You can solve for x by factoring, you can solve for x by completing the square, and you can solve for x using the quadratic formula. The one way that you cannot solve these particular equations is by graphing. And the reason that is if you look carefully at the equations, there's only one variable, which is x. So you actually need two variables in order to graph it. You need x and y. So if we have something that looks like this, where we have the exact same equations but they're set equal to y, you can graph them. And if you want to graph them, you can go back to the tried and true method of making a table, picking values for x, and then finding out what the values of y are that match up with those values of x. That will always work to graph a parabola. So if you can't remember how to do it, or if you know, it's just escaping you, you can always go back to the table. But making a table of values is kind of tricky because you don't always get what you want. You don't always get the picture that you want. So, for example, if we're looking at this, we've got values of y that are very large, and so graphing them is not going to be feasible. It's too big for a small graph. And then same thing with the second table, you've got values that are too large. So if we do graph these, we get 0, 4, negative 2, 0, and negative 3, 1. It's kind of a tricky looking graph because you're not really sure where to go, but you can graph more plots, more points, plot more points, and you can end up with a parabola. Same thing with the second one. If you plot the points, 0, negative 3, 2, 1, and 3, 0, you can kind of get the general shape. You're not entirely sure where the vertex is, but you kind of have an idea. And then that last one, same thing. Graph 0, negative 3, 2, 1, 3, 6. There it almost looks like a line, and you have to go back to negative 2, 1 to actually see that it is a parabola. So this method works, but it's not always reliable. So we're going to actually talk about the strategies for graphing quadratic equations. So the first thing that you need to know is that every parabola, when you graph a quadratic equation, well, first of all, quadratic equations are always parabolas. So whenever you have x squared, you know that it's going to look like a parabola. And all parabolas are symmetric, and they have an axis of symmetry, which is the red line that I have indicated here. And it's where the parabola's vertex goes through. Okay, and then another thing about quadratic equations is you always have a coefficient in front of the x squared. And you can tell whether the graph is going to go up or down by looking at that coefficient. So if a, the number in front of x squared, is positive, it's going to go up, like a happy face. If it's negative, it's going to go down, like a sad face. So, let's do an example. So if I have y equals 2x squared plus bx plus c, I look at the 2 and I can see that 2 is positive, so it goes up. And if I have y equals negative 3x squared plus bx plus c, that negative 3 is negative, so it's going to go down. Okay, so the parabola crosses the y-axis at the value of the constant term in the equation. So the constant term, again, is the number that's all the way by itself. So if I have y equals negative 3x squared plus 14x minus 5, the constant term here is negative 5. And that's always going to be the y-intercept, because if you let x equal 0, then y is going to be negative 5. And those first two terms in your quadratic equation are always going to drop out if you let x equal 0. So the constant term, the term that's left over, is always going to be your intercept. The constant term shifts the graph up or down. So it's that number that's out there by itself that tells it to go up or down. The shape of the parabola is not affected. Everything else stays the same except it just moves it up or down. So we're going to look at a couple of examples really quick. This one has a constant term of 4, so you can see that the y-intercept is 4. That doesn't mean that the vertex is there. It's just saying that the graph crosses the y-axis at y equals 4. So if we have the same equation and we change that to a 1, we're going to have the exact same parabola, but it's just going to be moved down 3 units. And then if I said let y equals x squared plus ax minus 1, negative 1 is going to be where it crosses the y-axis. Negative 1 is going to be 2 units lower than 1 in the previous graph, so we're just going to keep moving it down, and you get the parabola that crosses at y equals negative 1. Okay. Let's just kind of review really quick. If you have y equals negative x squared minus 8x minus 13, we can see that it opens down because the coefficient of the first value, the coefficient that goes with the x squared, is negative. So it opens down. And then I can see that the y-intercept is going to be 0, negative 13, because when I put 0 in for x, I get negative 13. If I gave you this equation, y equals x squared minus 8x plus 13, I know that's going to be a parabola that opens up, and I know my y-intercept. I know that my y-intercept is going to be 0, 13. So that's 2 very good pieces of information about graphing parabolas, but we need more. So we're going to employ completing the square to figure that out. So completing the square helps to determine 2 things. It helps you figure out the equation of the axis of symmetry. So if you remember that line of symmetry that goes straight down the middle of the parabola. And then it also lets you know the y-coordinates of the vertex. So if I have a parabola that is in this form, a quadratic equation that's in this form, I can see that it opens down. I can also see that the axis of symmetry is x equals negative 4. I look inside the parentheses and then I take the opposite of it. So the axis of symmetry is negative 4. The vertex is at y equals 3. So I know that my axis of symmetry is negative 4 and the vertex is at negative 4, 3. Let's look at another example, and we're going to go through this very slowly so you'll understand it. So first of all, I can see that it's going to open up. I can see that my axis of symmetry is x equals 4 because it's opposite of what's inside the parentheses. And then I look at that negative 3, and that negative 3 is telling me the vertex. So the y value of the vertex is negative 3. So let's do some examples that make sense. So complete the square to graph this equation. So the first thing we can tell is the graph opens up, and we know the y-intercept is going to be 0, 2. Okay, from there we need to make it look like it's in this form. Right now it's in standard form, and we need to turn it into this form in order to figure out those other pieces. So I'm going to take my equation, y equals x squared minus 4x plus 2, and I'm going to break it up like this. Get it ready to complete the square. The 2 goes on the outside of the parentheses, and then the x squared minus 4x is going to go on the inside. So what I need to do is I need to figure out, I'm going to take that negative 4 and I'm going to take half of it. So half of negative 4 is negative 2, and then I square it. So you square negative 2. So negative 2 squared is going to be 4. So I've added 4 now, and normally, remember, if I add to one side, I have to add to the other side. So normally I would add it to y, but I want to keep everything over on the other side. So the way that I'm going to keep this scale balanced, in order to keep this equation balanced, is if I add something, I also have to take it away. So I'm just going to add 4 in the parentheses, and then I'm going to subtract 4 outside of the parentheses, because that means that I have a net addition of 0. So this is how we're going to complete this square. So now that I have x squared minus 4x plus 4, I know that I can write that as x minus 2 quantity squared, and then plus 2 minus 4 becomes just negative 2. So now I have it in the form that I want it to. It's in this form of, It's in this form of y equals x plus a quantity squared plus k. So I know a little bit more information. I can take that -2, and I know my axis of symmetry is x equals 2, because again, you're taking the opposite of that number. And then I also know that my y value of my vertex is going to be -2. So I can take all this information and help graph. So I'm going to draw my coordinate axis. My y-intercept is 0, 2. The axis of symmetry is at x equals 2. So I'm just going to put a dotted line at x equals 2. And then that kind of tells me where the x-coordinate of my vertex is, but now I know my y-coordinate of my vertex is -2. So I just go along that axis of symmetry, go down to -2, and make a point. So I have 2 points here, and I know it's symmetrical, but just to be sure, what we're going to do is we're going to pick a point. So we're going to let x equal 4, plug it back into the equation. So we get 4 squared minus 4 times 4 plus 2. So when we let x equal 4, then y is going to equal 2, because we get 16 minus 16 plus 2. 16 minus 16 goes away, so you get y equals 2. So when x equals 4, y equals 2, so that's another point I can plot, 4, 2, and then finish my parabola. So that is the graph of that first parabola. We'll do a couple more examples. So next example, complete the square of this graph. So we can see by looking at the equation that it opens downward. We can see that the y-intercept is 0, 2, and we'll rewrite this. Now, the first thing we need to do with this equation is we cannot have a negative x squared to start. So we need to divide both sides by -1. So dividing both sides by -1, we get -y equals x squared minus 2x minus 2. Now, you can't really have the -y either, but we'll take care of that in a few steps down the line. Right now, our main goal is to kind of manipulate the numbers so that we can complete the square. So that's what we're going to do first. So we get -y equals x squared minus 2x minus 2. We're going to put it in that form so that we can complete the square. Take half of -2 and square it. Half of -2 is -1, and -1 squared is going to be plus 1. So if we add 1 inside the parentheses, we'll subtract 1 outside of the parentheses. So when we do that, okay, so we have x minus 1 quantity squared, and then minus 3. Now is when we can take that -y and get rid of the negative sign. So now we're going to divide everything by -1 again. So we'll get y is equal to negative the quantity x minus 1 squared plus 3. So now we're in the form, the final form that we can now begin to graph. So we look at that -1 inside the parentheses. That tells us that our axis of symmetry is x equals 1. We know that our y-coordinate of the vertex is going to be 3. So when we graph it, we will graph our y-intercept at 0, 2, our axis of symmetry at x equals 1. Then we know that the y-coordinate of the vertex is at 3. So on that axis of symmetry, go up to 3 and make a point. And then we'll plug in a value. If we let x equal 2, then we get -2 squared plus 2 squared plus 2. So we get -4 plus 4 plus 2, which is 0 plus 2, which is 2. So we plot that point. Now we have some points to make a parabola, so we can graph the parabola, and it looks like this. Okay, one more example. Complete the square to graph the following. So we can see that it's negative, so it graphs downward. We can see that the y-intercept is going to be at -8. So we'll divide both sides by -1 because you can't have a negative in front of the x squared. So we get -y equals x squared plus 6x plus 8 We'll divide it up to make it ready for completing the square. Half of 6 and then square. So half of 6 is 3 and 3 squared is 9. So we'll add 9 inside the parentheses and then we'll subtract 9 outside of the parentheses. So that gives us negative y equals x plus 3 quantity squared minus 1. Now we'll divide both sides by negative 1 so that we can get rid of that negative with the y. So we get y is equal to negative the quantity x plus 3 squared and then plus 1. And now we're ready to finish graphing. So we can see our axis of symmetry is x equals negative 3. The y coordinate of the vertex is 1, so we know it's going to be at negative 3, 1. When we go to graph, we can graph our y-intercept at negative 8, the axis of symmetry at x equals negative 3, and the vertex at negative 3, 1. You can pick any point that you want to figure out what your third point is going to be. It doesn't have to be symmetrical. So, but in this case, we'll let x equal negative 6 just to make it symmetrical. I just like symmetry. So let x equal negative 6, plug it into your equation, negative 6 squared minus 6 times negative 6 minus 8. So we get negative 36 plus 36 minus 8, which equals negative 8. So we know when we go negative 6, negative 8, there's our point, and that is our parabola.